Hello and welcome to my video about clean coding principles using C Sharp. So first of all, we'll see why do we want to write clean code and why it is so important. We'll see how to write clean names. Uh, Also, we'll see how to write clean methods, functions, and comments. Then we'll see how formatting shall be done in order to enhance readability, how to handle errors, and we'll see how unit testing can contribute to clean code. We'll see how to write clean classes, conditionals, and last we will see how to stay clean after we have a clean code base. Good. Uh, Next, what would be the motivation to write clean code? So, in case you are a programmer, and I assume most of you are already programmers or attempt to be, after this course, I hope you will be better programmers and write more clean and robust code. And of course, there will be code for some time ongoing, even with these new code generation tools. We'll never be rid of code, even with these ChatGPT and code generation tools, which will help us enable more rapid and fast code. But we still have to do these little tweaks and adjustments in order to have a fully working software solution. Good. I want to talk a bit here about ChatGPT. So it's a very useful tool. I'm not saying you shouldn't use it. It provides a lot of examples and clues, but yeah, we still have to think with our mind. So ChatGPT is only a helpful tool. So, for example, I find a really interesting scenario here and how ChatGPT can create us some websites. So it's very funny. So it's if you know how this index HTML works and how ChatGPT assumes it creates a fully website with this. Good. Yeah, before talking about clean code, we'll see what bad code is. So first of all, why would you write bad code? Okay, so would you want to go fast? So for example, your boss tells you to ship a module, and you have to implement the solution, and then you create some bad code, some nasty code, which works, but it's a maintenance nightmare, and it would be a solution to create some bad code which simply works. But in the long term, this is not an option. Uh, or you want to finalize a module to get rid of a change, or why would you still want to write bad code? Because assuming your code base is already bad and it's not clean at all, then you will probably follow the same style and continue writing this bad code. This is, uh, yeah. And of course, if you want to implement something to just see it working, then you might uh, read some bad code to save some time, but in the long term, this will haunt you. Um, yeah, next we'll see here a diagram. You see the productivity at the beginning of a project, it's very high, it's 100%, but in time, if we have bad code and we don't take care of our code base to clean it up from time to time, the productivity decreases down to yeah, very low after some years. Good. What would be a solution if we had this bad code? Uh, yeah, we can redesign the whole system. This would be an option, so we have to analyze this a bit. I had it a couple of times, and redesigning the whole system is not a real solution. So because the old system has still to be maintained, and it can of course take a lot of time, 3, 10 years, and in this time frame, probably most of the team members are already gone. So the new ones will probably request another redesign, and we'll start from the beginning. But yeah, the best solution would be to keep the existing code clean. Of course, as a professional developer, which I assume every software developer is his aim to be professional. And your main goal would be to defend the code. And yeah, we have different strategies. So we have this, for example, these two theories, the broken window theory and the Boy Scout rule. So we'll discuss shortly about this. So the broken window theory says that if uh, if a part of the code, so if, for example, a window on a house is broken, then the other windows will be broken too, because this one broken window um, brings other broken parts, and after a while the whole house will be a mess. So that's the same with our code base. If we don't take care of a broken window, so as to say, so for example, a bad code place, and we don't fix it, then this will bring afterwards a lot of other bad code, and we'll have a mess in the end. So this is the broken window theory, and we have here the Boy Scout rule. So this said that if we do some changes in our code, in our code base, we should leave the code in a better state than it was before. So if we see something which is wrong there, just clean it up a bit, and so that it looks better, because this will help also us and all the team members in the long run. Good. Yeah, the art of clean coding is again something about the professional attitude and recognizing good code from bad code. It doesn't necessarily mean that you're a good programmer. You need to have the ability to transform bad code into good code. So a programmer with concepts, code sense looks at a messy module and sees options and variations to get from one state of the code to a better design. So next we'll see why would we want to write clean code. So reading in the end is harder than writing code. So if we write some bad code and some messy code, it will take us some time to understand it. After some time, if we read it again, um, and the technical debt is depressing, and it lowers our morale. So yeah, it's nice to have some good clean coding in order to be more effective. You're of course lazy, so if you write bad code, it means you have to write more code, which some part which are not working in its practice. So with clean coding, you should write the least amount of code lines in order to accomplish a goal. And yeah, of course, with clean coding, we avoid also technical debt, and it's faster. So if we create it clean and good structure from the beginning, it's faster and also easier to create clean coding. So here again, a nice picture I found on the internet. So how will are we able to measure the code quality? So you'll see the good code in the left side, uh, yeah, just some PDFs per minute. And we can measure this, and the bad code we get a lot of PDFs. Good. Um, Good. Next, we'll see how how the code should be written. So here at the top we see it's fast, down slow. So your boss actually wants you to deliver fast results. So basically he wants fast results, but he is not interested in the code quality most of the times. Ideally, we should have the kind of boss which thinks also on the code quality. But you as a programmer should be in this part here in the upper right corner. You want fast results, but also clean. As a developer, you're basically an author, and I will show you why is this. Uh, so each line written is read 10 times afterwards in principle. So you take care that the code you write is clean and be understandable by anyone who reads this from yeah, in the future. We'll see how a book is structured in the chapter, headings, and paragraphs, and the same can be can be seen also in code. So for example, in C Sharp, we have these namespaces, classes, and methods. So it's like being an author of a book. So everything you create is basically the, the work of an artist, basically. Uh, yeah, clean coding principles. Um, yeah, you have to have the right tool for the job to pick the best technology and the best implementation, and to have a high signal to noise ratio. So, for example, this is from radio signals. So the code should have only those elements which makes it relevant to not have too much, for example, comments or or uh, or code artifacts which are not contributing to the to the best approach. So, for example, if you don't take the best algorithm, or we create some bad indentation which makes the code harder to read, that means we decrease this signal to noise ratio. And of course, the code should be self-documenting, um, and express the most we can in the least lines of code. Good. Yeah, next we'll see how to pick the right tool for the right job. So for example, would you use this string here for regex validation? If yes, what would you do if you need to modify it? So if a new requirement comes that you should allow also some other characters, then this will be a nightmare. Um, yeah, also watch for boundaries to avoid mixing these technologies. Only how it's indicated. So for example, we should avoid dynamic JavaScript in C# code. We see here, for example, we can have HTML code which contains too much JavaScript, so JavaScript should be put in separate files. Mixing this can result in code which is harder to understand. And of course, avoiding inline CSS in HTML. CSS shall be put into its separate files. Um, and yeah, next we'll see an example how JavaScript and C# code can create problems. So for example, we have this script here, and we add it dynamically with this controls, and we add this script here. We see we don't have any IntelliSense, we don't see code highlighted here, so this can create problems. Better would be to do this directly in the front end. So you see here down below we have this code completion if we use Visual Studio, and then everything looks better. Also the indentation is done automatically. Um, Also, we have to stay native, so one language per file that we see to not don't mix C# code with CSS code and so on to store maybe, I don't know, HTML content in databases. Yeah, this can be problematic sometimes because yeah, fixing it and doing updates is not so easy. Um, yeah, if we stay native, then we can take benefits from caching of content. We get this colored functionality with Visual Studio, for example. We get syntax checked. Get this nice separation of concerns, which makes it much more easier to update code because we know where to search for styles and where to search for backend functionality. And yeah, makes code also reusable. So having this separation makes it much more easier to use certain components. And yeah, avoids also string parsing, and we can minify, for example, we can minify JavaScript files or CSS files if we use separate files. Good. We talked about a bit earlier about this signal to noise ratio, how we can increase this clean coding. So having a high signal to noise ratio means the code is clean and we don't have things which which obfuscate or makes the code less readable. So signals, so the code should be expressive and doing one thing, should be also well structured with, as you see in this structure with the namespaces, classes, yeah, and methods should be well structured. Uh, on the other hand, the noise can be created by having two huge classes and methods, repetition. So we'll see the drive principles, don't repeat yourself. And yeah, the noise can be created also by don't having enough nice space, white space, the formatting, the indentation, and the zombie code. For example, this is code which is not used. So for example, comments, which are code that is commented out, is basically zombie code which adds some noise to the code base. Good. How here is an example of such a code which has some I would say not needed summary comments. We'll see here. It adds basically it doesn't say something new. It just pollutes this method. Also, this region is not really needed. Um, we'll see we have here also some source control things which can be found also in source control. We should not put this comments like this because in history all modern code should be in source control system, and there we consider history why something changed. Good. Let's see how this can be improved. So this is much more cleaner. So we have the same method with a suggested name, and yeah, we get rid of these comments here, and it looks much better here and more compact. We talk about this. Don't repeat yourself principle is the same as denormalization to don't have repeat code. If we do copy and paste of a method, it means we have some part of this principle, drive principle, because we repeated some code. Um, and of course, the duplication decreases signal to noise ratio because we have to maintain much more code now if we repeat ourselves. And duplication also increases the number of lines of code, and it's a maintenance problem. Ideally, we should have self-documenting code. Um, yeah, basically the original programmer's intent to understand it is the most difficult problem, and well-written code and clean coding is self-documented with layers of abstraction and readability is enhanced. And we should avoid comments wherever possible and write such code which is self-documented. Good. Let's talk about naming, how to provide good naming. Let's see just an example where the naming is not so good. So we have here some identifiers. So X was upside down, G was living after breakfast, and what does would you remember this? Of course not. Or something else. G went with A on the road. So it's very hard to remember these things and what is X, G. So it's important to have good variable names also. Uh, yeah, in code. And we'll see here why naming matters. So let's see just a method. We have this public method G, and we iterate over the speed, and we create here and return something. What does this do? It's very hard to understand. So how can it be improved? We can write here suggesting names, and you see if we get to the prices return total. So it's much more intuitive to see what that this method does. Um, yeah, class naming guidelines. Of course, each class name should be a noun, have a single responsibility. So if it has multiple responsibilities and does more than one thing, then we should split this class into multiple classes. Uh, it should be also specific with a specific functionality, and yeah, avoid generic suffixes. So the class, how we define the class name is also very important. So let's see here some bad naming. example. So we have here this user info. So this info thing here at the end is not needed. Add some noise to the naming. Website business logic is also not a good name because it cracks too much code and it will be not clear and easy to maintain. My function doesn't say anything. The same with manager, which cracks a lot of code and will grow too much, and in the end it will be not so clear. Some better examples are we have this user simply without the info. We have this specific responsibilities. We have the builder, the repository, and we have the account. So the account, it's like in domain-driven design. It's just something, a domain object. Good. Regarding method, we can have not so good names like go, get, start, process, do it is not available. So these are not really good names because they don't tell the intent of what is go seem to do. A better name would be, yeah, just something more specific. So get registered users, send email, import document is valid card. So we should really think of good names because they makes code more readable. Um, Good, your methods and classes should not have side effects. So a method should do some specific functionality. Each method, for example, check password, should just check the password and shouldn't do something else like log users in. Get users shouldn't update last access time, and charge credit card shouldn't send emails. Validate order shouldn't save something. It should just validate. Um, yeah, we have also some naming warning signs. So if you see a name like this, save user and send email, it's not a good name for a method because it seems this does two things. So this should be split into two methods. The end here is not okay. So if you see save user, if something else happened, then we should split this into two methods, or the same with or. Um, Yeah, also we should avoid abbreviation to make the method clean and understandable. Is not the beginning of the programming era to save specific memory space with short names of variables. And we should talk about code in domain-specific language, like in domain-driven design. Uh, yeah, some bad examples of how to name a class for registering user, reg user, regist user, regis user. For example, the best thing to do is just tell everything, and this is more clear for anyone involved. Naming variables, so booleans. Let's see how booleans can be named in case of flags. Uh, for boolean values, so we have this open is not so good, start, status. It should be something which is true or false. So here we see some better names. So is open, this is a true indicator that tells us either this is true or false. If it's done, is active, logged in, and you see also when you check it, it feels more naturally and also be symmetrical. So if you use on, then it's not okay to have disabled the opposite meaning. So lock, unlock. You see, um, the examples on, off, lock, unlock, and main and max. So use the symmetrical variable names if needed. Methods. So method and function. So ever wondered what the difference between these two is? So both methods and functions are pieces of code which are called by name. Yeah, the difference is that methods are associated with an object, whereas functions can be called without having objects. And yeah, in this course further we will use these terms, methods and functions interchangeably. Good. Let's think a bit when should we create a function. So we assume we have a class, want to create a function. So maybe want to eliminate some duplication, some code that is specific to more parts of our code base, and then we will create a method. Um, yeah, maybe to have a better indentation. So we have a lot of if or switch statements, and we want to make it more clear what specific part of our code does, and we can extract the code into a method. Um, and of course, if something is doing more than one task, then we should create a specific and separate functions for each functionality. Less is more. This applies also in software development. So you saw earlier some examples of don't repeat yourself. So to have the least amount of code in order to accomplish one thing is the ideal solution. Yeah, code is a liability and has to be maintained, and of course, less is more in this sense. Um, Good. We'll see here how how this don't repeat yourself um, pattern looks like. So, for example, we have three checks, and all of them is very similar. How can we enhance this? We can extract here a method, and the common functionality should be put in that method, and only the things which are changing can be provided as parameters to this function.
Next, we're gonna talk about error code and how this affects clean coding. So we see the error code looks something like this. So we have this style of programming where we have a lot of nested if statements, for example, or while or whatever. And this makes the code much harder to read. So for example, if you have more than two if statements, then the code readability decreases dramatically. Good. Uh, Solutions for this, how we can get rid of these nested ifs. We can extract, for example, some methods here. For example, we can take some ifs and create a method. We can also fail fast. So this checking here, we can return earlier if something is not as expected. And yeah, also throw some exceptions in case of something is wrong. So we'll take these three methods one by one. What we can do, we have this style here. We have some ifs and a while, and here we have some complicated logic going on. What we can do here is we can, for example, extract this checking here and this business into a dedicated method. So for example, this do complicated logic, and we extract it, and yeah, it looks a bit more cleaner this way. Another thing we can do, for example, we have this method with some checking of the parameters. This doesn't look so good. What we can do here to make this indentation a bit much more readable, we can check these parameters at the start of the method, so we don't have this nesting here, so it looks a bit more cleaner. Next, we can also return earlier. So for example, here we have 1, 2, 3, 4 ifs, so it's very complicated to understand this logic. What we can do here is we can return here earlier. So this makes the code a bit more inline and easier to maintain. What we can also do to make the code more clearer and readable, we can, for example, if we have such a checking, for example, we can see here how to check for zip files or archives. So this is not very clear what this does, but we can of course create here a method, which the name is very important because it tells us what this does. So anytime, instead of checking for this these strings here, we can have a method that just gets the file extensions as an input and return true or false if this is valid or not. Good. Another thing about clean coding in methods is that methods should do one thing only. The main reason is it helps the reader to understand the method. If it does more than one thing, it complicates a bit the logic and it's not very clear what it does. Yeah, also if a method is doing only one thing, then the reuse is enabled, so we can use this method from multiple places. And yeah, also the naming is easier if you have one method which does some concrete thing and which is very clear, then it's also easier to name this method, and also the testing is easier. And yeah, of course it avoids side effects. So doing one thing, it's clear that this does only this thing and not something else. And we should also, in method, we should avoid Boolean arguments, because a Boolean argument passed to a method means that we do a check and we have different branches based on this flag. So if this flag is true, we do some logic. If it's false, we do some other logic. So better to create separate methods for this checking. Here we see an example. So for example, we create here user, and we get this send email boolean flag. So it's not so clear what it does. It creates a user or send me email. So better to create to have two methods, one which is responsible for creating user, one only for emailing users. Output parameters are not really recommended because the intent of the function is not clear. So you pass in some parameters, but normally the parameters you pass to a function are used inside that method, not to modify them, but instead to do something with them, to calculate a result. And with object-oriented programming, output parameters should be avoided, because if a function must change the state of something, have it change the state of the owning object. Next, we're going to talk about parameters of functions. So I see a lot of questions about this. So how many parameters should a method have? So looking at this method, we see we have here three parameters. User, send email, and email format. It's not so clear what this does because it has too many parameters. From my point of view, it's better to have only one parameter in this case and create separate methods for the other parameters or the logic that is intended to be executed in that cases. Monadic functions. So what are monadic functions? So functions, these are functions with exactly one input parameter. So these are okay functions. So I would recommend to have only functions which have one or two parameters most. For example, we see here a clean function, register user, and we get the user object as an input parameter. On the other hand, we have the dyadic functions. So these are functions which have two parameters. Yeah, they're harder to understand than monadic functions. So because they have two parameters, so you have to understand what exactly these two parameters mean. So you have to take them independently and see what they do inside the function. And yeah, because they are two parameters, as I said, you have to pause a second to ignore the first parameter, and ignoring a parameter can cause problems because we should never ignore parts of our code. An example where dyadic functions are perfectly relevant. So for example, we can have such a structure where we have the point. The point is with the XY axis, and we can declare it only like this with two parameters. Triads are functions which have three parameters. They are obviously yeah, a couple of times harder to understand than functions with two parameters, and yeah, they are significantly harder to understand. And well, one solution would be to create such we have this, for example, this method with a lot of primitive parameters. The solution would be to create such argument objects which takes all these primitive types in it. So for example, a user. Talking about method length, so there are some indicators which tells us that a method is too long. For example, we have too many white spaces and comments which are not relevant. So comments are yeah, you should have a very good reason to add comments. So normally comments should be avoided, and the intent of the code should be expressed with the coding style. And yeah, if you need to scroll through a method, it's basically a sign that it is too long. And yeah, if it is hard for you to give a name to a method, then it means it's a bit too long and do too many things. And having also multiple conditionals, it's it's also a sign that it does more than one thing. And it's hard to understand. So if a method is hard to understand, it means probably it's too long. And the method normally should be rarely over 20 lines. Um, so I mean, so much as you can see on a screen, and not rarely over 3 parameters. Good. About a function behavior. So for example, we have this command query separation principle. So this tells us that function should either do something or answer something. So yeah, if a function does both things, so this leads to confusion. So it should do something or return something. For example, here we have a method which what it does is publishes a report and returns a report. So it's not clear what this does. So, and another one is we get a number of items and we add an item, but it's not clear in this context what this number of items is and why it is returned from the add item method. So this command query separation is a very important aspect in the overall architecture of the system, and all methods should yeah, should basically respect this separation. So another concept is if we have methods which are longer, so we should prefer exceptions rather to returning error codes. How this is implemented. So also this returning error codes is a violation of the command query separation principle and leads to deeply nested structures because error code has to be checked immediately. And this is an example here. So we see here this nested structure with a lot of checking of ifs and else. How can this be simplified and made more readable? We can use this exception checking catching here, and all the logic is done here nicely. Okay, what else can we do to improve the readability? So for example, we can have this try catch thing here, and we can have a lot of complicated logic going on into the try catch here. This can be enhanced by extracting this logic into another method, and this makes it more clear how the exception handling is done and what exactly we do here in the try catch block. Next, we're gonna talk about code comments. So code comments is a very important aspect of clean coding. So comments, normally you ask yourself, how do you write code that's readable and maintainable with comments? Well, it depends. So if you see a lot of comments in your code base, so you should have a warning sign, because this is not very recommended. So we should ask ourselves, are comments great or a code smell? So normally we should prefer expressive code over comments, and we should only use comments when code isn't sufficient. So these are rare cases. We will see also such examples later. We should avoid some comments. We should avoid redundant comments which doesn't say anything. We should avoid intent comments, so intent should be expressed through code. apology, warning comments are not indicated. Zombie code, so this is code which is commented out because of different reasons. We should avoid this bloated header with this standard header of a company or something like that. And the defect log is also not recommended because the defects should be tracked in source controls. Some examples here. Yeah, redundant comments and something like this. You see here we just tell something which is obvious from the code. These are we should avoid them. Also, this default comment, this summary, it's not really recommended if it doesn't tell something relevant. And also here we see a comment for a method which doesn't help us really much, is just adds some lines of code which are not really useful. We should avoid also intent comments. So for example, we check the status is 2. This is not really clear. We can improve this structure by creating an enum for this 2 value, and this tells exactly what it checks, and then this comment is not needed anymore. We should also avoid apology and warning comments. We shouldn't apologize if we create code. We should make it clear. So we should write such a code that it's maintainable, and also in the future when we'll read it, we should be able to understand it easily. Yeah, we should fix them before commit or merge. And if you really need to do something later, add a to-do marker comment if you have to. So for example, we can add such to-do statements. And also Visual Studio has a nice task list where you can see all your to-dos from the whole solution, and then you can come back later to fix them if needed. We talked about zombie code. So zombie code is some commented out code for different reasons, because it didn't work, or our whole methods which are not relevant anymore, and you see them commented out. So you should ask your some questions. So what did this section do which is commented out? When would it be uncommented? I'm sure nobody knows that. Was this accidentally commented? Do I need to refactor this too, maybe, when you come and make some changes here? And yeah, you should use source control for code history, so you shouldn't have this kind of comments in your code. About this bloated header, so for example, you see we can have all the files, older files have this such header comments, so this is also not relevant anymore because it's also outdated. You see 2009, and it doesn't add any value. So the history should be visible in source control, so author history. And this is repeatable code which appears in all files, and if you need to change something, then you have to update all the files, and this is not funny. We should also avoid such comments which tells us which work item we requested this change. So these things should be visible in this source control, in TFS or Git or whatever you're using for change control tracking. Yeah. So next we'll see also some benefits of comments. So there are also clean comments. So we saw earlier how to-do comments can enable us to have this task list here, and at a later point we can come back and fix some things. We can have summary comments which describes the intent at the general level higher than the code, and are often useful to provide a high level overview of classes. Well, the risk is we shouldn't use them to simply augment poor naming or code level intent. And yeah, we have also documentation code. Yeah, this documentation code here below is something which can be really expressed in code. So we express here something more general. If someone wants to read about this functionality, then go to this link and read about it. Good. if you're ever faced this question about to write a comment at a specific moment, so you should ask some questions. So the first question would be if yeah, could I express what I'm about to comment in code? um, yeah, there are multiple tools. So if you want to express something, you can use intermediate variables, eliminate magic numbers with enums, or refactor to a well-named method. There are different techniques. Or should this be a source control commit message if you want to comment something? Or am I explaining bad code I just wrote instead of refactoring? So comments should generally be a last resort. Next, we're gonna talk about code formatting. So formatting of the code is very important because it helps the readability of the code. So we'll talk here about this vertical formatting, so the space between lines of code, the distance. We also have this formatting on how variables are declared and dependent functions. So dependent functions should be declared one below other so that they are more readable. So if you read a function, you know that if this function calls another function, normally this should goes below this dependent function. Horizontal formatting is also important to have the same tabs and spaces between characters and lines of code. And we have this nice shortcut which in Visual Studio do automatically formatting based on the rules which are present on the system. Good. Next, we're gonna see how error handling should be done. We discussed about to use exceptions rather than returning error codes. So using exceptions lets us focus on the business logic. So we do not all this checking and returning of error codes. Instead, we catch the exceptions in a central place. Yeah, a layer above. We should also don't return null, so methods should not return null. Yeah, instead throw exceptions, so we should separate this handling. And instead of returning null, we should return an empty object better, or an empty list of objects if the return value is a list. Good. And also we should not pass null as arguments to functions because then we have to do this checking in the method itself. But instead, if we do this checking before, then we are able to handle this case and have more clear code. Speaking about clean code, we have to talk also about unit tests. So unit tests is a very important aspect when writing clean code. So with unit tests in place, so we should enforce writing unit tests. This means that the code will be more modular, more testable, and more maintainable. So no, ideally, we should create for every piece of code we write, we should also create a unit test, and this enforces us to write more robust and modular and maintainable code. We should also keep the same clean coding guidelines for writing unit tests as production code. We should keep our tests clean. Yeah, have one assert per test, and we have this first this acronyms comes from the unit test should be fast, independent, repeatable, self-validating, and timely. Yeah, with timely we mean mainly to be able to write unit testing at before writing the actual code. And we have also these 3 lines of TDD. We see them here. So first of all, we should write a failing unit test, make the test pass, so write some production code, and then we are able to refactor because we have this unit test which ensures that the code is still working. Enough with unit testing. As I said, there's a whole video about that which I made earlier, and now we're going to talk about classes. So what are the triggers to create a class? So mainly when we have a new concept, yeah, abstract or real world. So like in domain-driven design, we have a new domain, we should create a task. A class should have low cohesion. So the methods inside that class should be very related, and if classes are small and related, we can reuse them. They will get small, and yeah, the reuse is easier, and also the complexity is reduced, and we should create classes when we have a group of data which is strongly related. Speaking about strongly related data, we should not create such things, so things which are doing too much, because yeah, the readability is enhanced if all the things are in one place, and the reuse is encouraged. So here we see this Swiss Army knife, which does too many things, so it will be a maintenance nightmare if we compare this to a code base. And also here we have a kind of church here, and it's also parking lot. So this is a class which does two things. So normally we should separate such classes to have two classes instead of one. Okay, also class names are very important. We should give specific class names. Are some examples of bad naming. So these are like magnets which attracts functionality which should not be put in this class. So a class with too many functionalities is hard to understand, and will be a maintenance nightmare. Here are some names which we shouldn't use. My functions, common processor manager. I used a lot this manager name for all kind of stuff, but this will attract like a magnet bad code, and the classes will be huge, and in the end it will be hard to maintain these classes. Good. Let's see an example of how we can increase this cohesion in classes. So for example, we see here yeah, basically how we can create a class with low cohesion where too many things are put in a single class. So we have here a vehicle example, a class which does all these things, update pricing. Instead, we should focus on creating separate classes for each functionality. So for example, you can create a vehicle class, a vehicle maintenance, and a vehicle finance class. And yeah, everything will be grouped nicer. We talked about also this proximity principle, so we should be able to read this code from up down. So methods which are calling other methods should be in descending order. So we see we have the validate data, which is put below this method, and we have also another method which is this is the normal flow, and it aids the reader to better understand this code. Next, we're going to talk about conditionals, some examples and how to write better conditional statements. So if, then, else, while loops, for loops, this kind of things. Oh yeah, here is an example in C# how two Boolean can be compared. It's easier if you use this directly, this logged in without putting this equal sign. We should also assign Boolean implicitly. So for example, we have here this example where we do this checking, but C# has this nice feature, and a lot of programming languages have this this nice and easier notation. So for example, also here we do this checking, and we can use here the ternary operator, which which makes the code yeah, not so many lines of code. Also, an important thing about naming variables and Boolean values, so we should not be anti-negative. This makes the conditions much harder to understand. So instead of doing this is not, if we put another negation at the beginning, then it's very hard to understand. We should go with positive values. Also, we should be strongly typed. So if we have here a constant somewhere in the code, normally I recommend to put such strings, magic strings, as a constant on the class level to be able to distinguish them, especially if they are repeated throughout the code. Then it will be very hard to modify them at a later point. So it's much better to have, for example, an enum where we have this employee type manager, and this way we are strongly typed. And yeah, if something changes, then we get compile time errors. Speaking about magic numbers, yeah, we have, for example, this sentence here: Tom went to the number 2 dealer to buy under 42. This is not very readable. We should be able to have clear names instead, and this makes the code much more readable. So we see here, we do a comparison. So what does this if say? It's very hard to understand at the beginning, but if we declare here a variable, an intermediate variable with a clear name, we know exactly what this if is checking here. And also another example, if we stack a status for a code, number 2 is not really clear. If we create here also an enum with the status active, for example, then it's clear what this checking is doing. Good. Next, we're gonna talk about complex conditionals. How can we if we have some conditions to check, how can we improve this code? So what exactly are we checking here is not really clear as a reader. We can improve this by creating introducing a variable, or we'll see later also a method, which is better, but we can introduce a variable which exactly tells us what this condition is doing and makes the code much more understandable. And better is to create also a function which can be used from different places. Good. Another concept is to use this polymorphism of object-oriented programming languages. So instead of having such a switch statement which checks here the status of the user and executes specific logic in case of user states, for example, we can improve this by extracting this functionality to have a login user method, and each user which is active, inactive, blocked should have its own class. So with the help of polymorphism, we will be then able to execute the specific logic based on the type of the user. So the last thing we're going to talk about in this video is about how to ensure that we keep the existing code base clean, and how and when to refactor when clean coding is needed. Of course, once a code is written, you will have to work with this code to maintain it, and yeah, in case it's hard to understand, it's not really well written, then yeah, we have to refactor it to restructure it maybe, in case it's difficult to understand. And of course, unit testing helps us a lot. So if we want to refactor code, we have first to write a passing unit test, and then if we change the code, with the help of the unit test, we are able to see that we don't break anything. Speaking about code reviews, so code reviews are a very important aspect of clean coding. Um, Code reviews done with the help of another colleague, for example, it promotes clean coding. We also can set guidelines, so all the developers from a specific team should follow the same coding rules, and readability is also ensured when code reviews are performed, so that if something is not okay, we can react and update the code. Yeah, clean coding can also be ensured with working in pairs. So, for example, getting a colleague and doing some real-time code reviews, the quality of the code is increased, the naming and refactoring will be easier. Yeah, and last, I want to talk about from my point of view, is the most important thing about clean coding and how clean coding can be maintained and enforced in a team. So we should think of this broken window theory. So we should not let one window to be broken, because one window leads to other broken windows. So we should react and do the necessary fixing and updates in case our code gets the wrong way. And also the Boy Scout rule, it means that every time we change a specific area of our code, we should ensure that the that the code we leave behind is cleaner, or at least the same coding standards as it was before. So we should not introduce technical debt. Uh, yeah, finally, the resources which inspired me for creating this video. Yeah, most of them, the principles can be found in this book from Robert Martin, Clean Coding. A lot of useful principles, which basically tells us how to be able to be professional and write clean coding.